Now let's welcome Jorge Chairez, a research professor at our Institute of Advanced Materials for Sustainable Manufacturing, who will discuss robotics and additive manufacturing technologies at the service of civil engineering, the current contributions of Tecnológico de Monterrey. Thank you very much, Dr. Chairez.
Thank you. Well, thanks again for being here. I will present another area that we are developing in the research unit where I am participating in. And this one is related to different application of additive manufacturing together with robotics. Here we want to bring these solutions to solve one of the biggest problems that we have, especially in Latin America, about civil engineering safeness for workers, for masons. You know, masons are, masonry is the profession that is, let me say, producing mostly of the persons that are affected in the spinal cord because injuries, because they fell down and could suffer of accidents. And for many years, construction has been considered as one of the most reliable, effective, and affordable industry all over the world. It has to provide high value, productivity. It has a lot of requirements related to the time that you need to, that you will have to accomplish complexity, quality, and so on. And you know, the current complexity in civil engineering is bringing a lot of new aspects that are related to not only to the advances that we have, but also in the problems that we need to face. For example, the decline in productivity, the low quality of final constructions, if the rules and norms are not followed, and the time overruns, the vanishing skilled labor force, which is a real problem all over the world. You know, finding good masons, architects that could work in producing good enough constructions is a mess. And you know, especially in zones that are, let's say, that could be sensible to earthquakes and some other possible problems around civil construction, has motivated that new areas are going to be explored in the near future, especially considering that civil engineering is using, construction as an industry, is using materials that are considered one of the most, that are related to industry that are considered one of the, or mostly contaminants in the world, like cement production, like casting industry, and so on. And you know, if we look at the main challenge of civil engineering recognized by the specialized organizations, we can see that sustainability, environmental protection, and the professional practice are most of the, or the main ones that are considered by, that should be faced in the near future. And what are the proposals up to now to face these challenges? Of course, creating sustainable communities, balancing sustainability with profits, which is quite important, and designing for future transport needs. And maybe one of the most important one is rebuilding the existing infrastructure, considering what we are doing for helping workers in this area. And in particular, if we consider the Sustainable Development Goals proposed by national units, worldwide units, is related to engineering for sustainable development. And in this sense, automation in the construction industry could offer, for sure, a good way, a reliable way to increase productivity, transform the collaboration with all other sectors in industry and science, and especially thinking about the safeness, the safety and the well-being of workers in here. You know, this is one of the things that we are very worried about, especially because we understand that beyond the necessity of elevating the productivity, we need to attract highly skilled talent to accomplish the production of these civil structures on time. And all of these are the key goals that we can attain with automation, or transforming what we are doing with automation, not only thinking about producing new blocks or new ways of bringing robotics in industry, but to create some modular construction that can accelerate how we get the final design, or the final product of civil engineering. And here, this is the reason of this talk, how to understand how with robotics we can revolutionize construction. What we are thinking, okay, you know that robotics is the intersection of many disciplines. Engineering, technology that could produce machines, and that could replicate or collaborate, or in some examples could substitute human actions. And you know, traditionally we understand robotics in industry like these kind of things, working on specific areas, controlling the scenarios, very well-known environments, even that we have these traditional industrial robotics, or this kind of, let's say, advanced collaborative robots. But if we take out the robots from the control of the scenario, the things change a lot. You know, exposing robots to the real environment, working in open doors scenario, imply a lot of challenges that we need to face when we are developing robots. Because we understand that we can use robots for a lot of things. All the additive manufacturing systems are actually a kind of robotic device at the end. And if we now understand that robots are everywhere, in every area in industry, why not bring these robotic solutions to construction? First, we understand that construction is still today one of the most labor-intensive industry in the world. I mean, I think it's incomparable with respect to many other industries. Also, we need to understand that it is quite time-consuming to produce very big civil structures, and will demand a lot of persons working in a very, unpleasant conditions. You know, producing roads, civil constructions in very high temperatures, exposed to the environment. So it's not good for these workers. And that's why, since maybe 10 years ago, there's a kind of industry transformation started, bringing these kind of big robots to make these prefabricated structures that can be transported from the design center and the construction center to the real environment, to put a prefabricated house by 3D printing system based on this kind of technology in the real social areas. However, if we go back a little bit, we understand that robotics in construction is actually not a new thing. All these machines are indeed robots. But you know, the way that we want to apply robotics in construction is quite different. It's not like that, but it's something that looks like this. To automatize wall construction, to use robotics to construct devices in open environments, and to have the chance to collaborate with masons, thinking about the social impact that this could have on masonries. But you know, if you look at these big robots, one thing is passing in your brain, or is in your brain, is cost. How costly this could be for companies here in Mexico and in Latin America. And you know, now this is not a new trend. It's something that is happening all the time in new construction industries that are taking advantage of what we can do with mobile manipulators, with collaborative robots, and this is automatizing what happens in industries all over the world. And when we consider the requirements that we will have developing these new robots for civil engineering, we need to consider a lot of things. First, big robots that can handle different weights, different torques. We need to consider a more reliable instrumentation that could work open doors. And we need new control techniques to regulate how the robot is moving in a very changing conditions. So based on that, we started analyzing what could be the areas where we can propose new things. Bringing together, again, as I mentioned it in the morning, machine learning tools, more advanced sensing systems, predicting potential errors, analyzing the effect of failures that we can have in the robotic device, and preventing the operation of this robot here. And we considered that we can have two potential areas where we can implement what we know. The second one at the bottom makes tries to bring the robotic device to construct this kind of civil structures like houses, but that cannot be applied here in Mexico, especially in the south, because the earthquake conditions is not possible. Actually, the current regulations here in Mexico don't allow to construct this kind of constructions. But we all know that kind of constructions in Mexico. Bricks together with mortar in the middle, and then to start working with the robots. Doing that could be, let's say, more realistic for the kind of problems that we are facing here in Mexico. So thinking on the necessity of boost the task efficiency and reduce operating cost, as well as reduce the number of injuries, which is one of the most important aspects that we are trying to solve, we analyzed a lot of examples of civil robots, or what they now call civil robots, working all over the world. We analyzed a lot of these kind of applications for demolishing, for carrying bricks, for doing a lot of stuff that are common in civil construction. And based on this analysis that we did like 2 years ago, we found an interesting possibility of bringing this process that we know for the basic manual operation in civil construction to try to develop a full autonomy civil engineering robotic aid process. And now the tendency is, or the trend is doing something like that. To collaborate, to provide an environment where humans and robots could collaborate in civil engineering with a more challenging condition to the designers of these robots, because should work in a very, very challenging condition, under very challenging conditions with these civil structures, but that should be smooth enough to work together with humans. And this leads to our approach for robotic in construction. We started understanding ergonomic aspects, financial aspects, and fortunately, there was a seed funding project that we won together with the University of Alberta, with my colleague Yu Xianshen, and we started constructing this idea of bringing robotics in construction as a joint project, thinking in this concept, creating the entire pathway to construct a mobile manipulator that can handle bricks automatically, to put them on the brick, that can be aided with this brick carrier robot that we are developing in Guadalajara. All these systems are in Guadalajara, and with new solutions for simplifying how to handle the bricks together. And we developed a twin, a real robotic twin. There is one in Alberta, there is one here in Guadalajara. We are working with they both together just to replicate what we can do at both sides. We are constructing everything. I mean, the metal mechanic part, the instrumentation, control, artificial intelligence elements here. And we also constructed the 3D printing system for making bricks automatically. And together with a colleague in Mexico City, we developed that automatic gripper for handling bricks. And the idea is to use or to take advantage of gravity to reduce the load that we need to apply to the robotic arm. And then with an artificial intelligence tool, we started to detect the bricks in a wall to find the correct position for the new bricks that should be inserted as a new tool. And as I said, we made a new development of a control algorithm that considers a hybrid position force scheme, because when the robot is moving, it should not carry about the load, but when it has to carry the brick, the control action should change in order to handle the brick correctly. We developed the mobile platform and adaptive control to reduce the energy that we are using in the robotic arm, and of course, fully satisfaction of design requirements that we propose. This is the robot. There is a video just showing how this small robot made of aluminum could carry about 5 kilograms. And yeah, it's that one. This is one of the first tests that we made using a kind of very simple crane that can work together with in an open environment. We tested this outside, and this is the additive manufacturing system that we have for deploying clay, up to now clay, but we are working with the mixing process that actually we will try to develop together with Dr. Trevino about using this, a couple of continuous pump to deploy the material with this 3D printing system. And just to save some time, I will move to the next part. This is the kind of gripper that we are developing now. This is not needing actually a robot over there, because or a motor. Let me say a motor over there, because this is the part that will be more exposed to the environmental conditions. So we need to avoid all the instrumentation that we can here. And what we find is that we can put the same type of gripper together with a linear actuator to carry the brick in a simpler way compared to what we have now in the robotic area. And now we are working on that device that can carry the bricks automatically. So together, we can produce the bricks with the printer, we can carry the bricks with this device, and we can put the bricks on the wall automatically. Everything controlled in a cyber-physical system design. And yeah, what we are expecting is to have this, let's say, integrated cyber-physical system ready to be exposed to the industry, maybe next semester, because we are working in the 3 areas together. And I hope that we will invite you to see it working. I mean, all the robots together that are not needing external cameras and nothing else. They are working in a kind of coordinated manner using a multi-agent strategy based on online optimization control algorithms. So yeah, this is more or less what I want to present about what we did in this area of robotics for cyber engineering. Thanks a lot.
Thank you very much, Dr. Chairez. We're going to start our Q&A session. Anyone has a question for Dr. Chairez? Let me see if I have one.
I think the challenge is low-cost manufacturing in this case because of the conditions in countries like Mexico where labor is very low cost. So how you are going to tackle that issue if you want to really go forward into your solutions to be really available for construction sites in Mexico, in developing countries?
That's why we started doing this by ourselves. I mean, not buying robotic arms that are available out there, and to try to implement what we know, especially those things that could be very expensive. And even more, we didn't consider to have this big robot that could be very difficult to transfer to industry. So what we want to have is small sections that could be put everywhere together, working independently, and just supervised by the masons. And in that sense, we can simplify the acceptance, I hope, simplify the acceptance by the companies. I suppose companies will be okay with that, but masons may not. So we need to involve them in using this technology to check that the robot is doing the things correctly. Like, I don't know how to call it in English, but like the person that is helping. You know, in Spanish it's chalán, no? But in English it could be like the co-worker of the masters in masonry. So here what we want to do is to try to bring this technology closer to the masons, not to the companies. And hopefully.
Probably the solution is to have very specialized type of jobs.
Yeah.
Like building a fence.
Yeah.
And that will be your area where you are going to put all the robotics to work to build a fence.
Yeah.
And something that is more, not for the whole construction, but for specific parts of the construction site, no?
Yeah. And we are now thinking about replacing some of the parts that are in the robot by additive manufacturing solutions. So just to simplify the replacement, the maintenance, and all the stuff around the robot. But you know, we are working on the three robots in parallel. So it's a lot of work, and we need more students too that want to work in this, because you know this is a particular application of robotics that is not common for example, for mechatronics, doing robots for constructing houses. It's not common. So let's see if more people are interested in this. And of course, this is a exciting area considering what we can do for masons, because a lot of persons that work in construction may suffer of terrible injuries. So we want to help on that, at least with these ideas.
Thank you very much. Dr. Dora, please.
Yes, I was wondering about the final quality of the job, like in comparison with the one person does.
We will tell you when this will be ready together. I mean, all the robots together. And of course, we need to make the comparison with the traditional ones. But still, because we will have the robot, for example, we can control how straight is the wall when we are constructing everything. So we can make an objective analysis on how we are constructing everything. That part of the job is not ready yet. I mean, we need to consider the quality index of the construction as part of the control action that is reorganizing how the new brick is deployed on the wall. So, yeah, we will tell you.
Thank you very much, Dr.
Thanks a lot.
Chairez.